Okay, so let's look at 5 through 8 now. It's kind of like 1 through 4, only this time we do have words associated, like real-world examples showing what these vectors will be doing. For instance, a balloon rises at a rate of 6 feet per second. So because rising is insinuating going upward, this is why we show that, and we also show the magnitude being 6 feet per second. All right, so let's do wind coming from the north. So if here's north, south, east, and west, and we're coming from the north, it's like we're starting from north and going downward. This actually means the same as going south. Okay, so coming from the north is the same as going south. So therefore, we're going to show that we're starting here going south, and that the magnitude of this vector, let's call it W for wind, is going to be 15. We could put units, 15 miles an hour. So there's the answer for number 6. Okay, so an airplane heads southwest. Okay, so here's again north, south, east, west. And southwest is insinuating, in fact, right in between south and west. So it's a perfect 45-45 split for that third quadrant. Okay, so if I'm heading that direction and I draw it, it's going to start here and go that direction. Make sure that you do have arrows. Make sure you do have the dot. And its magnitude for this airplane, we could say, is going to be 220 knots. Okay, so let's do this last one. A ship sails on a bearing of 300. So this is different. These first three, we're talking about the rectangular direction. Okay, this is just like the normal unit circle, if you will, where you start at 0 degrees here, and it's 90, 180, 270, and 300. Well, with bearing, you're actually going to start, a good way to remember with bearing is that ships used it with the North Star. That north being up, you're going to start 0 degrees is going to be here. So it'll be 0, 90 degrees, and then 180, and then 270, and then 360. And because you're going to sail on a bearing of 300, it's basically going to go, here's 90, here's 180, here's 270, and 30 more degrees is going to show that the ship is traveling this direction. Okay? Again, there's 90, 90, 90. 30 more would give us that 300 degree bearing direction. So we're going to draw something that looks like that. Okay? And this is the ship, so we'll say S for ship. And it looks like absolute value, but it doesn't mean absolute value. It means magnitude. So the strength of that ship is going to be 20 miles in this respect. So notice, these were velocities like feet per second, miles per hour, and knots. This is an actual distance. So magnitude can do both the strength and the distance of something. And that's what the answer would be for 8. Okay. As far as the components go, if I looked at this vector, I went nothing to the right or left, so the x component is 0. And then I went straight up 6, so it'll be 0, 6 are the components for the vector, okay? Or the vector components. This one went nothing to the left, nothing to the right, so it's 0 again for x, but it went this time downward, so we're going to have a negative magnitude, a negative y value of 15. And then now we have 220 traveling at this direction as far as in this quadrant 3, this 45-45 split. So how are we going to get the components here? Well, we're going to go 220 times the cosine. In this case, we have to find what that angle is. So again, we've been saying this unit, the world revolves around you. So there, at the dot, is where you're at. And if I were to say, what is the rectangular angle, not the bearing, but the rectangular angle, it means if this is 0, how many degrees does it take to get there? Or you could do the negative route, either one. Let's do the positive route and say 90, 180, 225. So we're going to do 225 as the degree angle, and that's the x component of the vector. Then we'll do 220 times the sine of 225, and that's going to give us the y value of the vector, okay, the y component. So let's go ahead and go to the calculator real quick and see what we're going to get for those values. So let's go to the calculator and put 220 times the cosine of 225. That's actually incorrect because I need to change my mode to degree mode, 152 that is. Make it my default and go back by pressing 4 on the current document. So now you can see in the upper right hand corner I have degrees, and I can just copy this and see that it's going to be on negative 155.563. So negative 155.563 is going to be the x component of that vector. And now if we do the same, but this time we are going to do it sine, because we want the y value, we'll have 220 times the sine of 225, and we get the same thing, which makes sense because it's in the third quadrant, which is negative negative, like a negative x, negative y, and the numbers are the same because it's at the 45-degree angle, almost like that root 2 over 2, root 2 over 2 business. All right, so you get those components for number 7. All right, so now we are going at a bearing of 300. So the first thing that we have to do is remember that these angles that I was multiplying these magnitudes with are directional angles. Okay, they're unit circle angles. They're not bearings. So I need to look at this 300-degree bearing as a rectangular angle. And I can either do it visually from 0 degrees to here, or from the negative route all the way to there. Okay, if I did the positive one, it will be 90 degrees plus another 60 degrees, because we know these two would equal 90. So you're going to get 90 plus that 60 is 150, or some of you might have chosen to do 180 minus this 30, so that you got 150 degrees. So the cosine of 150 degrees this time would be multiplied by the magnitude of 20, and then you'd have 20 times the sine of 150 degrees. And that, let's see what we get from those places. Just real quick before I continue, remember that equation to change bearings also to rectangular. You could just do 90 minus whatever they gave you as bearings. And if I go to my calculator, I'll say 90 minus the 300, and it's either negative 210, or if I wanted to see the coterminal, I could add 360, which is how we got the 150 that we got visually. Okay, so now 20 cosine. So 20 cosine of 150, then we're going to do 20 times the sine of 150, and these are going to give us the x and y components of that vector, which come out to be a negative 17.321. Oops, 321 that is, not 231. So 321. And then the y value of a positive 10. Let's just make sure by seeing, are there any more decimals? And no, there are not. Okay, so those are the components of that vector. Now the magnitude, this is pretty easy. You're just going to take a squared plus b squared, and then take the square root. A squared plus b squared, take the square root. Again, remembering to put those negatives inside the parentheses. And then that squared plus this squared, take the square root, so on and so forth, in order to get those magnitudes here. Okay, so let's go ahead and go to the calculator and see how we can input this. So we're going to do the square root of parentheses 0 squared plus parentheses 6 squared. We don't need the parentheses, but I'm doing it just so that you get in the habit, and you see that you get a magnitude here of 6 feet per second. Okay, so 6 feet per second is the magnitude. Okay, so over here we're going to look at the magnitude, and the magnitude we can get the same way. We're going to do 0 and negative 15. So the square root of parentheses 0, and then the negative 15, this is why I'm doing the parentheses with the other ones, because I want you to remember to put that inside. And notice that we get a positive 15. Even though we're traveling down, magnitude is always positive. Okay? Hence, I think that's why mathematicians chose to use it with these absolute value, even though that's not what we're actually doing. We're not taking the absolute value, okay? So it will be 15 miles per hour, okay? And if you're seeing the pattern here, this should be the 220 knots that they said in the words, and this should be the 20 miles. But if you needed to make sure, you would just do, again, the square root of a squared plus b squared and see what you get. Let's go ahead and do that with this last one. We won't do it with both of them, but we'll just do it with one more. So it's going to be the parentheses negative 155, we'll round it a little bit, 56, and then we're going to do the plus the square root of the other one, the negative 155.56. Yes, we are squaring them, and in fact, you see that it would round up to the 220 that we got. Okay, for the sake of time, we don't have to do the last one. All right, so the directional angle, we're going to look at, so we looked at these components to get the magnitude. We're also going to do the same like we did on 1 through 4 to get the directional angle. Okay, so it's going to be the arctangent of 6 over 0, that's y over x. Just like this would be the arctangent of negative 15 over 0. This would be the arctangent of 155.563 over negative 155.563. Otherwise, the arctangent of negative 1. Okay? And then the arctangent of 10 over negative 17.321. Okay, so 0, 0, I have a positive, 0, 6, I have a positive, positive, so this is going to be the first quadrant. I have a positive, negative. This is going to be the fourth quadrant. I have a positive x, negative y, that's the fourth quadrant. Negative x, positive y, that's the second, and negative x, positive y, that's the second. Remember, the 1 and 4 we're going to leave as is when we do these answers here. Whatever the calculator spits out, that's what we're going to give it. But 2 and 3, and in this case we only have 2's, we're going to add 180 to whatever this is right here that the calculator spits out. So whatever angle it spits out, we're going to add the 180 because it's in quadrants 2 or 3. Okay? So let's see what we get with arctangent of 6 over 0. So the arctangent of 6 over 0, whoops, we're going to get a positive or a negative 90. Okay? And the fact that we were traveling visually upward, this one's going to be the positive 90 degrees. Okay? Let's do the next one. We have negative 15 over 0. Okay? And we're going to get a positive or a negative 90. So this one was traveling downward, hence that's where we're going to get the negative 90. And some of you might opt to do a positive 270, which is coterminal to that negative 90. That's fine, but it isn't required. Okay. So now we're going to do the arctangent of 1, and we're going to add 180 to whatever it gives us. Okay, so there's that angle. And we're going to add 180 to get 135. Again, we did that because it was in quadrants 2 or 3. Okay, this negative x positive y showed that it would be in quadrant 2. Okay, and sure enough, that looks like it's going to be, whoops, let me make sure that I did this one correct. So it is the arctangent of southwest at 220 knots. So that should be, okay, something wasn't quite right, and I saw an angle of 135, which from 0 degrees, whoops, from 0 degrees would actually be right here. So I just caught a mistake, and I'm glad I did, because it should be a negative and a negative here, because it's in quadrant 3, which is negative, negative. I even said that here, but just forgot to put my negative on that y value here. So it should have made this a negative y over a negative x, which in your calculator would have been a positive. Okay, so this should have been a positive 1. Okay, that we're still going to add 180 to, and that looks a lot better. So 225 is what this angle should have been. And no worries, I mean, mistakes are good, just like this. they're actually really good to see and further deepen your understanding of, trusting these numbers. So I saw that 135, I was like, that's not quite right. And you could do that on the test and be like, I might have missed something. And most likely, I'll tell you right now, it's mostly negatives. Not only in pre-calc, but also in calculus that we'll make mistakes with, as you saw me do. Okay. All right, no worries. We got it fixed. Let's move on to number 8. This is going to be this negative x positive y, so we're going to add 180 to what we get. And this is 10 over that 17, 3, 2, 1. Here we go. So the arc tangent of control divide 10 over this negative 17.321, and we get this, that we're going to, again, add 180 because it's in that second quadrant, and we get the angle should have been, the angle should be traveling at 150 degrees, which is definitely what we can see from what we did up here earlier, showing that 150 degree direction. Okay, so again, that 150 degrees matches up with what we showed here. The 225 matched up what we showed here, and so on and so forth. Okay? All right.